approximate date is the Earth furthest away from the Sun? Okay, so the Earth furthest away from the Sun. So the Earth, the planet Earth, revolves around the Sun in an elliptical orbit, something like this, with the Sun situated at one of the foci. Okay, there are two centers, two foci. The Sun will be situated at any one of those, and the Earth will revolve around this Sun in an elliptical orbit. Okay. Now the position of the Earth when it is closest to the Sun, is called perihelion. It happens in the month of January, 4th Jan. Next, when this Earth revolves around the Sun and ends up at a position which is farthest away from the Sun, somewhere here, let's say, that position, when the Earth is farthest away from the Sun, is called aphelion. Is called aphelion. It happens in the month of July, which is the date is 4th of July. Okay. So the correct answer here is at what approximate date, not the accurate date, but approximate value. It is beginning of July, 4th July, 3rd, 5th July, whatever. So beginning of July. Beginning of January, you have perihelion. End of September, okay, you have equinox. In the month of September, month end, you have equinox, autumn equinox. Next, question number 2. If pressure altitude is 22,800 feet and elevation of 22,000 feet, what is QNH? Okay, so elevation is 22,000 feet. So let's say this is your airport and the elevation of this airport from mean sea level, QNH is 22,000 feet. Is 22,000 feet. Pressure altitude of this particular airport is 22,800. Now pressure altitude is always measured from standard pressure setting 1013. Now 22,000 pressure altitude is more than the elevation by 800 feet. That means the datum standard pressure setting datum is below the QNH pressure datum. Okay, and that's why this pressure altitude is more than 22,000. So if this is your QNH or mean sea level, standard pressure setting datum will be below that. Standard pressure setting 1013 is below that QNH pressure datum, and the measurement will begin from the standard pressure setting datum up to that airport elevation. So you can see this line is bigger than this line. So 22,800. Now the difference between 22,800 and 22,000 is, that difference is 800 feet. This 800 feet, right? So we can convert this 800 feet vertical distance, okay, difference into corresponding pressure difference. How? We all know that a pressure difference of 1 millibar is equal to a height difference of approximately 30 feet, accurately 27 feet. So therefore, a a height difference of 800 feet between these two pressure levels will be equal to how much pressure difference? Cross multiply, that will be equal to 800 divided by 30, which is 26.6, approximately 27 millibar. So we all know that this is standard pressure setting 1013 line. So the QNH will be less than 1013 by what value? Okay, QNH will be standard pressure setting 1013 minus pressure difference So 1013 minus 27. 1013 minus 27 is 986. So as you go to higher levels, atmospheric pressure decreases. So QNH pressure level is above standard pressure setting datum. Therefore, its pressure value will be less than standard pressure setting. So here QNH is 986 millibar. So the correct answer here is approximately option A, 985, the closest option. Next, question number 3. Directions are measured. Always all directions are measured from the north datum, from the north datum, and directions are measured, always measured clockwise. They are always measured clockwise. So clockwise from north. Okay. The highest value of longitude. Now, how many longitudes do we have? We have 360-degree longitudes on the Earth. So this is my Earth. We have a prime meridian, 0 degree. So we have longitudes in the eastern hemisphere like this, longitudes in the western hemisphere as well, somewhat like this. So in total we have 360-degree longitudes. These 360-degree longitudes are divided into two different hemispheres. 180 degrees in the western hemispheres, another 180-degree longitude in the eastern hemisphere. If you are to represent this Earth on a flat sheet of paper, it will look something like this. The midline will be the prime meridian, 0 degree. There will be 180-degree meridians to the eastern side, 180 east, and another 180 west meridians to the in the western hemisphere. Okay, so the highest value of longitude is found close to the poles along the equator at Greenwich anti-meridian. So this is the correct value. Now we have, let's say this is another form of the Earth. I am drawing the view of the Earth from the North Pole, from the top of the North Pole. So this is your North Pole. This will be your prime meridian, 0 degree, 180-degree anti-meridian east and west, 90 east longitude, 90 west longitude. So, like I said, there are 180 meridians in the western hemisphere. So this is your western part of the Earth. You have a total of 180 meridians. Then another 180-degree meridians, 180, total of 180 meridians in the eastern part of the Earth. So you have another 180 meridians in the eastern part. So the highest value of longitude is 180-degree anti-meridian of any particular meridian. Okay. So in this case, they have considered prime meridian, and the anti-meridian of this prime meridian will be this line, international date line or 180-degree anti-meridian. So option C is the correct option. Now the highest value of longitude is found at Greenwich anti-meridian. Highest value of latitude, okay, of latitude is found close to the poles. We know that latitudes begin from the equator. Equator is a 0 degree parallel of latitude like this, and the maximum value of latitude will be North Pole or South Pole. So option A refers to latitudes along the equator. So that is irrelevant. Next, question number 5. A great circle track joins two positions alpha and bravo. Both are in the south hemisphere and in the western hemisphere. What is the difference between the great circle track between these two positions? Now, difference between great circle tracks, difference between two great circle tracks is equal to convergency, is equal to convergency. So convergency has two definitions. The difference between two great circle tracks, and the second one is the angle of inclination between two meridians. Okay, so here we will have to find convergency in order to find the difference between the two great circle tracks joining these two positions. So first let's find convergency. Convergency equals to d long into Convergence equals to d long in degree into sine of latitude. So what is the difference between these two longitudes? 150 west, 140 west. So 150 minus 140 is 10 degree. Sine of latitude. Now here we have two different latitudes. Find the mean average of that. 57 and 63. So the average will be sine of 60. So sine 60 whatever multiplied by 10 is 8.6. Consider 9 degree. So convergency is 9 degree. Now we have to determine whether this convergency will be an increment or a decrease. So for that we will have to draw a DIID diagram given in the chapter 2. DIID. So this is the northern hemisphere, this is the southern hemisphere. Okay. This is flying eastbound, this is flying westbound. Now here you have 57 south 140 west, 63 south 150 west. Okay. So 140 west and 57 south. Okay. Another is 63 south 150 west. Correct. So point A, point B. So great circle track will be passing through the nearest south pole. This is your northern hemisphere, northern direction, south direction. So point A and point B. What is the difference between A and B? So if you are going from position A to position B following this great circle track, so you are going in what direction A to B is? A to B is a direction of southwest, correct? And look at this. Now you are in the southern hemisphere, so pay attention to this portion of the diagram. And you're going in what direction? Southwest. So southwest is this one. So in the southwest part of this quadrant, we have written I. I means increase. So your great circle track difference, the difference between the great circle tracks at A and B will be an increment of 9 degree. Okay, will be an increment of 9 degree. So option A is the correct answer. Next. Golf is in position so and so 35 north, 34 degree, 45 minutes west. For a particular date, sunrise at this particular latitude is listed as 0715 local mean time. Air almanac timings are local mean time. What is the time of sunrise at same location given in UTC? Okay. So if sunrise happens at 7:15 LMT time, we have to convert this LMT time into corresponding UTC time. So let's draw this simple diagram, formula based numerical. So 0 degree longitude. So your UTC times are kept with respect to 0 degree longitude or Greenwich meridian. Another longitude is 34 degree, 45 minutes west. Okay, 34 degree, 45 minutes west. Now LMT time here is 0715. We have to find UTC time with respect to 0 degree meridian. Now 0 degree meridian is to the east of 35 degree, correction 34 degree 45 minutes west longitude. And we all know by rule that eastern longitudes run ahead in time compared to their west longitudes, right? So what will be the answer here? The answer will be UTC time will be running ahead of LMT time. So UTC is LMT plus the difference between the timings at these two longitudes. So 0715 plus D long. What is the D long? 34 degree 45 minutes divided by 15 degrees. So 0715 plus 34 degree 45 minutes divided by 15 degree. That is 2 hours 19 minutes. 2 hours 19 minutes. 9 hours 34 minutes. Okay. So the correct answer is option Charlie. 9 hours 34 minutes. Nautical mile is defined as a unit of measurement of distance equal to the average length of 1 minute of latitude. Correct answer is option Bravo. Nautical mile. The definition of nautical mile is average length of 1 minute of latitude. 1 minute of latitude equals to 1 nautical miles. Okay. Option C is the definition for 1 kilometer. Next. A Gaudic line is a line that connects what? So there are two lines. Isogonal line, lines joining places of equal variation, and agonic line, lines joining places of zero variation. So agonic line is positions that have 0 degree variation. Positions that have same variation is isogonal. Positions of equal magnetic horizontal field strength. That's fine. Next, question 9. Position A is given. Position A latitude is given to you. Position B, position latitude and longitude. Distance between them is 350 miles. B is to the east of A. What is the longitude of position A? So here we have been directly told that B is to the east of A. Okay. So A is here. B is to the east of it. The distance between A and B is a total of 350. B is 45 north. B is 45 degree north and A is also 45 degree north. So same latitude and B position is 45 degree 15 minutes east. 45 degree 15 minutes east. We have to find the longitude of position A. Now A is to the east of, A is to the west of position Bravo. So that means the value of longitude of position A will be somewhat less than 45 degree 15 minutes east because it is to the west of it. So let's look at the options 37, 48, 51. So the only option which has a value less than 45 degree 15 minutes is option A, 37 degree east. So only this should be your correct option or your answer, but we'll find it out. We'll solve this numerical. So this distance is nothing but drumline distance of 350 nautical miles. D long in minutes into cos of latitude. Latitude is the same latitude 45. So d log in minutes equals to 350 divided by cos 45. So 350 divided by cos 45 is equal to 494.9. That is 495 minutes. Convert this minutes into corresponding degrees. You have 8 degree 14 minutes. Right? So position of A will be longitude B, which is 45, which is 45 degree 15 minutes minus the difference between the longitudes 8 degree 14 minutes. So 45 degree 15 minutes minus 8 degree 14 minutes, that is equal to 37 degrees. Okay, so option A, like I said. So you can save, so you can look at the sum. Okay, and by looking at the question and looking at its options, you can just make a very good educated guess, eliminate unnecessary irrelevant options, and you will save your time like this. So instead of solving the whole sum in your exam, you can just look at the options, you can draw this diagram, get a rough idea, and then you can estimate the answer. Look at the options, whether the answer that you have in your mind is there in any one of the options given to you. Okay, and then that is the most probable answer. So option A. Question 10 last, the departure between positions A and between the first position, let's say A, and the second position B is so and so. What is the longitude of X? So departure is nothing but your rumline distance. So rumline distance is 1200 miles, d long in minutes into cos of latitude. So cos 60. So here the first position is at 100 degree east. And the second, we have to find the longitude of second position. Now, if the second position is in the eastern hemisphere, so I'll explain it to you. So we have two possibilities. You can just draw the diagram and guess the answer. We have a prime meridian in the center. We have 100 degree east longitude. This is our location number A. Location A. Now the second location, okay, can be in the eastern hemisphere to the east of this longitude. If it is to the east of this longitude, it will have any value which is more than 100 degree east. A value more than 100 degree east. If the second longitude is to the west of this longitude, but in the eastern hemisphere itself, not in the western hemisphere, in the eastern hemisphere itself, it will have a longitude value which is less than 100 degree east, which is less than 100 degree east. Now look at the options here. We have one value which is more than 100 degree east, that is 140 east, and other two longitudes are in the western hemisphere itself, both the longitudes. Okay, so let's first find out this. The solve this cos 60 is half, so d long in minutes will be equal to 1200 into 2, that is 2400 minutes, that is 40 degrees. 40 degrees. So the difference between the longitudes is 40 degrees. So there are two options. Option 1 or situation 1, position B is position A plus D long. Option number 2 is position B longitude. Position B longitude is position A minus D long. Position A is 100 east plus 40 gives you a value of 140 east. So like I said, if the new position B, second position, is to the eastern side, its longitude will be more than 100 degree east. So we have gotten 140 east. Second scenario, if it is to the west of position B, so what we do is 100 east minus D long 40, which is 100 minus 40 is 060 east. So it will still be in the same hemisphere, eastern hemisphere, but the value will be less than 160. So the only suitable option here is 140 east. So option A is the correct answer. So this concludes our lecture. I hope you have understood all the 10 questions, the answers, the explanations I gave. Keep practicing, keep working hard, be consistent. Do watch my other lectures in which I have solved all the time questions from R.K. Badi, Oxford, Keith Williams, as well as other lectures of VOR, ADF, Great Circle, Drumline, Convergency. I have also solved questions from other sample paper number 3, sample paper 4, 5 and 6. So do watch them. Thank you for your time. I request you to share this channel with your friends, this video with your friends, and subscribe if you haven't yet. Hit the like button if you have liked this video lecture. I'll see you in my next video lecture.